Hello students, in last class we were doing the method of analysis of negative feedback amplifier, and we were doing the identification of the topology of the feedback. We have taken the shortcut or prima facie method of identification of the topology. Now we'll take the actual method of identification of the topology. Okay. Now for the identification of the topology, just look at the point A of step 1. We have to find out, is the sampled output signal a voltage or current. Secondly, we have to find out, is the feedback signal being mixed in series or in shunt with the external input signal. Okay, we have to find out these two quantities. First of all, sampling, and secondly, mixing. Okay, now how can we find these two quantities? This is the method. To find the type of sampling, we have to first short the output. If we short the output, that is if we make V naught equal to 0, if feedback signal, except whether it is voltage or current, becomes 0, then we can say that it is a voltage sampling. Okay. Secondly, if we open the output loop, that is if we make I naught equal to 0, if feedback signal XF, whether it is voltage or current, becomes 0, then we can say that it is a current sampling. Okay. And to find the type of mixing network, if the feedback signal is subtracted from the externally applied signal as a voltage in the input loop, we can say that it is series mixing. And if the feedback signal is subtracted from the externally applied signal as a current in the input loop, we can say that it is the shunt mixing. Okay, it is as simple as this. Okay, now we will apply this method in our practical circuit. Okay, first of all we will take this circuit. Okay, now look, for identification of the sampling signal, if we make this V naught 0, then feedback will become 0. Okay, so that's why we can say that it is voltage sampling. Okay, secondly, for mixing, this feedback voltage Vf, the voltage across Re, is being mixed in series with this Vs. This Vf is basically opposing in series with this Vs. Okay, so that's why we will say that is series mixing. Okay, now next circuit. Again, same case is here. If we make V naught 0, then feedback will become 0. So this is voltage sampling. And again, this Vf is being mixed in series with Vs, or this Vf is opposing this Vs. Okay, that in series. That's why this is series mixing. Now again, next circuit. Now, if we make this voltage 0, okay, then there will be no feedback voltage from output to input. So that's why this is voltage sampling. Again, voltage across this Re1 is appearing in series with this and basically opposing. So that's why this is series mixing. Now let us take this circuit. Here if we make I naught 0, if we make I naught 0, okay, then VF will become 0. Okay, so for making I naught 0, we have to open the output loop. So if we open the output loop, I naught becomes 0 and VF will become 0. So that's why this is current sampling, not the voltage sampling. And again, voltage across this RE is coming opposing in series with VS. So that's why this is series mixing. Okay. So this is current series topology. Now next circuit. Okay, this circuit. Again, if we make output current I naught 0, then only this voltage will become 0. Okay, so if we open the output loop, then only feedback is becoming 0. That's why this is current sampling. And secondly, voltage across this RE2 is not coming in series with this VS. Here is a current division in the input loop. Current is being subtracted. Input current is being subtracted in the input loop. That's why this is shunt sampling. Okay, so that's why this is current shunt feedback topology. Okay. Now next circuit. Let us take this circuit. Here in this circuit, if we make V0 0, okay, then only feedback will become 0. Okay, that's why this is voltage sampling. Because if we make I0 0, okay, then basically this feedback is appearing from input to output because of this voltage. So making this voltage 0 is directly affecting the feedback. Okay, that's why this is voltage sampling. Now in mixing, input current is being subtracted from the input loop, from input to output. That's why this is shunt mixing. So basically this is voltage shunt topology. Okay, if you are not comfortable with this method, we can take another point of view. Okay, this is basically bookish method, but we can take another point of view of this method. Now look back again at our first circuit. Here sampling, we have to find out the sampling quantity and mixing quantity. Look, feedback, this is your output voltage, and feedback is directly related to this output voltage. We can, or in other words, we can say due to this voltage, feedback is directly affecting. Okay, so that's why this is voltage sampling. For mixing, I think you will not have any problem. Okay, mixing is same as we have previously discussed. In our next circuit, the same case is here in our next circuit. In this circuit also, feedback is directly related to the output voltage. Okay, not to the output current. That's why this is voltage sampling. But here in this circuit, feedback is appearing due to this output current flowing through RE and producing VF. So here sampling is of current sampling. Current is being sampled here. Okay. So you can take either of the point of view. You can explain either of the point of view in your examination also. But you have to explain one of the point of view. Here also, current is being, due to this output current, voltage is appearing across RE2, and due to this voltage, feedback is appearing from input to output. That's why this is again current sampling. Okay. Feedback is directly related to current as compared to voltage. It is not directly related to voltage, it is directly related to current, because due to this current being sampled and flowing through RE2, voltage is appearing across VE2, and due to this VE2, feedback is, the current is being subtracted from input to output. Input current is being subtracted from input to output. So that's why this is shunt mixing, and sampling is of current, so current shunt topology. Here in our last circuit, feedback is directly related to output voltage. Feedback is directly related to output voltage, because due to this voltage, current is being subtracted from input to output. Okay, so this is voltage sampling. In mixing, there is a current subtraction in the input loop. Okay, there is no voltage appearing, feedback voltage appearing in series with Vs, but there is a current subtraction from input to output in the input loop. That's why this is voltage shunt topology, and mixing is of shunt type. Okay, look, there is a in this input loop, there is a current division, input current division here from input to output. Feedback current is flowing from input to output, so that's why this is shunt mixing. So topology is voltage shunt feedback topology.